right. Kathy, thank you very much for that introduction and the invitation to come to talk to you all. Like you'd heard, I became a climate reality leader a few years ago and wear many different hats. And I'm pleased to see some of my friends from CCL on the call. I wanted to talk about this, but what I'd like to start with is what's your opinion? What's your thought is the most critical impact to the oceans from global warming? Any ideas? You can unmute yourself, I think, and
the heat, because everything else kind of comes from that.
Absolutely. Any other things with respect to how global warming is affecting the oceans?
Acidification, loss of
Very much.
species, ocean rising.
Yes. You've got a good suggestions, a set of things there, and I'm going to go through a bunch of those things. But for me, it's very difficult to say the most critical, except looking for a solution for what we've got. Now, what I'm going to be talking about is ocean heating, as you noted, and look at the extent and the effects of it. And then the sort of poor stepchild is the ocean acidification. So many people don't know about it. So we'll talk a little about the chemistry and look at the effects. So as part of climate reality, you probably have seen these slides before. The global surface temperature, we know that in 2023, it was the hottest year ever human recorded until 2024. And the jury is out to see what 2025 is going to be. I've heard it's probably vying for third, but it's certainly in the wrong direction. Now, and you've seen this before, the last 10 years, consistently, as we move higher in the later in the decades, they continue to be the last 10 years as the hottest on record. Now, we're fortunate because Earth is actually a water planet. 71% of the Earth's surface is covered by water. And it's a very good thing that we've got that. If you look at in the atmosphere, this is how much the global energy has gone into the atmosphere, heating us up in the air. This much is about into the land, heating up the land and such. Here is the amount in ice. Again, it seemed a pretty small amount, but the oceans, the deep oceans, have gone at least as much as the other three combined. In the middle territory, the 700 to 2,000 meter range, there's a lot more than that. And now the shallow, from surface down to 700 meters. The scary thing about it is half of the increase has taken less than 20 years to occur. So it's really good that we have the ocean there because there's a lot of heat that hasn't baked us. Now, you've probably heard of it. 93% of the extra heat has gone into the ocean. One estimate was if the ocean hadn't trapped that extra heat, the atmosphere would be, instead of 59 degrees Fahrenheit on average, it would be 63 degrees warmer, about 122 degrees Fahrenheit would be the average temperature. Clearly, the oceans are taking a lot of heat up for us. You might have seen this. This is where it's the changes in temperature. And you can see that the red is the El Nino years, and the blue is La Nina years, and the gray is sort of in between in transition. And you can see, we'll put a blow up of the more recent times. The El Nino years are corresponding with the much higher water temperatures. And if you take a closer look here, let's go from 2013 to 2023, the average ocean heat content. In 2023, it was above that, so that's not surprising. 2024, we'll just take it up to September, and you can see it was well above that. So there was an amazing amount of heat in the ocean. Now, September 26, 2024 was when Hurricane Helene was forming in the Caribbean and on into the Gulf of Mexico. And it was a massive storm. It was incredible because it basically had a footprint that covered all of Florida. And we'll see that it's incredible because on September 26th, it was a category 1, but by the next noon, it was a Category 4 hurricane. Now, there are plenty of Floridians that have gone through Category 1 or 2 hurricanes, and they don't think it's that big a deal. They had one day to prepare for a Cat 4, and it was devastating. And it didn't just stop with Florida. It continued on up through Georgia, past South Carolina and Asheville, North Carolina, and such. And they received a massive amount of rain, as much as 10 inches in some of the areas, as noted here at Asheville. Kind of as an aside, as I said, I live in Brookings and part of Curry County. And not that Yahoo News is exactly the best news source, but Yahoo News did a ranking of the Pacific Northwest, and the county that was to have the least impact from climate change was Curry County, which is kind of interesting. Well, the other aspect is they picked cities. Asheville, North Carolina was one of the cities they said would be least affected by climate change.
Yeah.
And they were destroyed. And even now, a year later, because of the massive amount of water, because of the mountainous conditions, they're still trying to recover. So no place is safe. Now, what I want to look at is some of the physical changes. When I give talks, I try to avoid getting into policy or solutions to a large extent that people can debate. Physical conditions, chemical conditions, those are the ones that are hard to refute. Now, as was exemplified by Hurricane Helene, there's increased evaporation with the extra heat, which means there's more moisture and more energy in the air. That leads to the more intense and rapidly intensifying storms. Now, I didn't say there are going to be more storms, but as the experts are saying, maybe the same number, but they're going to be much worse. They're also slower moving. And as they're slower moving, they last longer. And that means there's heavier rainfall totals and increased flooding. So it just compounds. All that energy in the ocean is manifesting itself in different ways. So at the same time that Hurricane Helene was happening, there was a hurricane in Acapulco that was going on. So it was plenty of energy in the oceans. Now, in Acapulco, the year before, had been devastated by a Category 5 hurricane. And that was amazing because in one day, it increased its wind speed by 115 miles an hour in one day, which is equivalent to having get calm and a Category 3 hurricane a day later. So the intensity and speed is just amazing. Now, as one of you mentioned, sea level rise is another aspect about the climate change. And you've heard about the glaciers and the ice cap, land ice that's melting and going into the oceans. There's also melting permafrost. And the permafrost is going to be contributing because that was locked up as ice, and now it's going into the oceans. You may have seen a recent National Geographic presentation about how some of the permafrost, as it melts and it changes the conditions, it's actually mobilizing some heavy metals, whether it's iron or even cadmium or others, and it makes it look, some of the streams, like an acid mine waste tailings mess. So that's not a small amount. It's not a small issue. So it's all part of sea level rise. The other thing that hadn't really thought about is that the pumping of groundwater, fossil groundwater, for irrigation takes it out from the ground and puts it into the rivers, and then that goes out to the sea level rise. Now, the other contributing factor is that as the waters warm, they expand. And so it's something on the order of a third to half of the sea level rise is due to the waters just warming up. So you can see there are a variety of contributors to all this, but all that's going to be of an issue. Now, this is an aerial of where I live in Brookings. I'm on the right side of the picture over in Harbor. And I have, this is a program that you can get from NOAA. You can access at NOAA. And it shows what sea level rise would be at many different places. So I did this for Brookings and did it, well, let's see, if we were to go up 2.5 feet. Brookings is pretty steep. If you've been here, you know that there's not a lot of wetlands around. You see a little bit up here, maybe as you go up the Chetco River. But if we were to go a little bit farther, maybe a 5-foot rise, you can start to see even up the river, there's going to be more of the land being affected. Well, that's not really the point I wanted to make with this. Harbor has an intake up the Chetco, a water intake. Brookings has its own, but it's about a mile farther up. The first year we were here, we had to go to the water district, the Harbor Water District, and get bottled water that was coming from Brookings. Now, that's something that's been happening right now, because when the tides come up in the summer, late summer, early fall, the water is slow going out into the river. That tidal, there's a tidal wedge that goes up on the bottom, which is where the intakes are. So if you have, even right now, there are times when we have to have water pulled in. If we even had a 2-foot raise, we probably would be having to change the infrastructure for our fresh water. Probably the same for Brookings. Now, if we go to the other end of the coast from where I am here, we have, looking at Astoria, you can see their airport here. This is what the average mean high water is now, some wet areas here. If it were to go up 2 feet, you would have a heck of a time getting to the airport. If it went to 5 feet, so much of this is underwater that it's completely useless. So the point is that there are places that have infrastructure in low-lying areas will be affected. Now, here's a website that, if you're interested, we could go and check out different places, or we can continue on. I will say, when I did it once, somebody suggested that we looked at Sandpoint, Idaho, but I was pretty sure that there was not going to be a lot of an impact for the climate change, for rising sea levels. Shall we continue? All right. Changes to the ocean currents is another thing that is going to be coming as a consequence of the global warming. This is an interesting diagram. When I was an undergraduate student doing a physical oceanography class, this is where I learned about this great ocean conveyor belt. It's a thermal haline circulation. Thermal means that it moves and is driven by the different temperatures. And haline is it's the density or the salinity that's driving it. Now you can see this basically goes everywhere in all of the major ocean basins, and which means that it's all connected. You have a parcel of water that over a couple thousand years basically goes everywhere in the different ocean, which means that global heating gets moved all around as well. Now look a little bit closer to home, as it were. We have in the Atlantic Ocean, you probably have heard about AMOC, or the Atlantic Meridional Overturning Circulation. Basically, as this water is moving across the Atlantic, over out through the Caribbean, through the Gulf of Mexico, up here towards Europe, that whole time the water is evaporating and it's heating up. Now, as it heats up, it pulls in a lot of air, a lot of heat. And as it's evaporating, it's taking the water out and leaving the salts behind. So as it's moving through here, it gets hotter and saltier. As it gets up in here, it's going to be cooling down, but it's still going to be salty. So as it gets up to this area, it's now lost a lot of the heat, which makes it denser. And it's still got a lot of salinity, which makes it denser. And the denser water will sink. And so now it goes down to the bottom, all along here, the Mid-Atlantic Ridge, past there, and around. So this is how it's driven around the world. And it's interesting because this is a fairly contentious question, but some of the new studies have said that there's an almost complete loss of stability in the system. And that's a problem. And to take a look at some evidence for it, we've probably heard that the poles are heating much more quickly than the tropics, except for here. which is where we have the Greenland ice cap. We have a lot of the ice in the Arctic, and that's melting. And that melting, it leaves fresh water that's going to be sitting on the top of the existing water, which is going to disrupt the circulation. Colleen, you had a question?
Great. So sorry to interrupt. I'm not seeing the slides anymore. I said someone says to click on view, then standard. So sorry. Keep going.
Yeah.
Did you get it figured out, Colleen?
I don't see standard. I clicked on view. I see speaker gallery, multi-speaker. I don't see standard.
It's right at the top on mine. And maybe if you say speaker, then try that and maybe that will work too.
Yeah, I'm not seeing it. I don't know. But I don't want to interrupt, so keep going.
We'll play with it and maybe it'll come back.
Okay.
So to continue, this is a weird anomaly. And if this continues, that means that this whole system could slow down or stop. Well, that's got some pretty significant effects. I grew up in Illinois, and I know why it's called the Windy City. I went through too many years in the winter. It's really cold. I've not been to Barcelona, but I think I'd rather spend my winters in Barcelona than Chicago. Beyond that, Calgary is even worse. It makes Chicago look balmy. And yet London, at the same latitude, is much, much more comfortable, which shows the massive amount of heat that gets carried forward. If this circulation, the AMOC, slows down, there would be a much less heat being carried over to Europe. And the heat would not be getting carried away from the tropics. So Europe would get into a very cold condition, and the tropics would be even more hotter. Now, other physical changes, they can see that there could be localized changes in winds. Hans?
Yeah, wouldn't that diagram you showed, because the Arctic, actually that area is warming twice as fast, wouldn't there also be less cold, shall we say? And it'll be a mix of that up in Scandinavia, less cold, more cold.
Yeah, there is that. From what I understand, the amount of heat that's getting carried through the AMOC up to upper Europe is much greater than, because the poles are starting off very, very cold. So relative increase there. But yeah, that's playing off there. It's all going to be some new equilibrium, probably the best way to put it.
And I'll just mention briefly, I have a cousin there who farms in Sweden, and he says that it's just been so nice and good for growing crops lately. Anyway, yeah.
Well, there will be some people that will benefit from all that's going on, but a lot of people are not. So, thank you.
Yeah.
So we do have localized changes in the winds, and for us here in the Pacific Coast, what does that mean? The big thing is, you're probably familiar, you've heard about the upwelling that we have off the coast here, and it can upset the balance of that. Like I said, things are changing, and so they're no longer going to be on the same balance that they have been. You're familiar with upwelling, probably. You know that as the winds blow, specifically in the summer from the north to the south, it pushes the surface water out. Now, if we have heating, it ends up being more of a force pushing the wind going south, pushing more water out, and that's all upwelling. Now, as a side view of what upwelling is, for anybody that's not familiar with it, basically, as the winds are blowing, in this case, into the screen, it's going to be forcing the water offshore. That's because we're in the northern hemisphere, and it's the spiral of the Earth and things like that, Coriolis effect. And so as that water near shore gets pushed out, it's got to be replaced from somewhere. Well, it's a good thing, because it gets replaced by the deeper, colder, nutrient-rich, oxygen-poor water that's been very deep in the water. Now, that's a good thing because the nutrients help the phytoplankton, which is food for the zooplankton, which is food for the fish and for us. But it's in a nice balanced system that hasn't changed very quickly for quite a while. But if we upset it by having it be sort of the upwelling on steroids, if it will, you have the potential for too much algae growth. Basically, what you're doing, you're adding a lot of fertilizer, and that leads to algal blooms, and that could lead to eutrophication. Basically, what that means is overproductivity. If they're not the zooplankton to eat it, the algae will fall to the bottom and they will decompose using up oxygen. We said that deep water was already low in oxygen. And so that's a real issue too. Mm. So we can end up having low or no oxygen zones or dead zones. It's interesting because as we'll see in a bit, the first time that dead zones, low oxygen zones were seen off Oregon was 2002. But now it's a regular season effect and it's a seasonal event. And it's the worst in 2006, but it's more recent in 2017 and 2018 it's happened. Now, hopefully you can see this.
Some can swim away. Some try to crawl away. Others might propulse away. Many are just too slow or stuck.
Dead zones of low oxygen water kill crabs, fishes, and other marine life. And the recent annual occurrence of dead zones in the nearshore points to dramatic changes in our ocean environment.
Today, we're just 2 miles off the Oregon coast, monitoring ocean conditions. It's hard to believe, but the water right underneath us might not have enough oxygen in it to support most marine life.
Prior to 2002, dead zones, which are areas lacking in oxygen, often called hypoxia, were not reported in nearshore waters off Oregon and Washington.
Sorry. So it's interesting that these changes have affected the upwelling, causing these dead zones. Now, there's an interesting aspect. You probably have heard about the proposed floating offshore wind here. And people are saying, if we put floating offshore wind, or if we did offshore wind here, that's harvesting the wind energy. And if there were less wind energy, then there would be less of the upwelling. There's very little data and few studies that have actually looked at that, but it sounds like it's a possibility. And the opposite idea was that, well, here, if we have increased winds that are leading to the increased upwelling, which is leading to the dead zones, maybe the offshore wind would be helpful in reducing that effect. And so the question is, are there any local data to support that? The person you saw at the very end is Jack Barth, who was the oceanographer at OSU, has been studying this for decades. Now, the pink picture or pink numbers over on the right are an indication of the number of days in Portland at the airport that were over 90 degrees. And you can see to the left that from 1980 up till 2022, 23, there has been an increase in the number of 90 degrees days in Portland. And that's just a representative of how things have changed. And I imagine that many of you can tell, sort of attest from your own experience, things have been hotter. And so it's not surprising that you're aware that it's hotter. If you look to the left side, it's odd that increase is down, but because there's stronger winds, that means there is more upwelling. Now, the question is, how much of that extra upwelling that's due from the winds could be balanced out by offshore wind? And there's probably 2% of the data you need for that, and a lot of people that are speculating. But it's an interesting question as to whether or not offshore wind might have an unexpected benefit. There are other areas that have upwelling that's been affected. I'll challenge your geography. Where do you think this is? Any suggestions?
Panama.
It is Panama. On the left is the picture that represents the productivity of the algae that are there. And this year was the first time in 40 years that Panama did not have the upwelling. And so the scientists are trying to figure out what happened, because it didn't just slow down a little bit, it disappeared. So it can be affecting different things, it can be affecting upwelling in different places. Now, moving on, a reduction in sea ice. You've probably heard of that as well. And the Arctic sea ice was pretty stable for a long time until very recently. And you'll see that if you see the little yellow lines around here, that was the average extent between 1981 and 2010. And this was the extent, this is the maximum extent that was on March 22nd this last year. So it's not that much different. However, when you go to the minimum, this was the average from 81 to 2010, the average minimum. And this now was September 2024. I pull your attention to a couple things here. Notice this average extent basically closed off everything down. There was no way to get around. There was not that ever sought Northwest Passage, except now there is. And so that has some amazing effects on international travel, international security, moving things by ship around. So the consequences of the reduced ice pack are significant. Now, it's interesting, too, if you normally would have ice out to here, all of this area would have ice that would reflect the sunlight away. If you have open water, much of that sunlight penetrates, heats the water, and then it produces more of a melting effect on the remaining ice. So it's a feedback, only it's a positive feedback. The more the water warms, the more the heat is going to be more ice is going to melt, which means the more water is going to melt, or ice will melt. So again, it's not something we want it to have happen. We also have localized heat waves. Here's a graphic that was prepared by the New York Times, and it shows just how much of the area of the oceans were considered to be having a heat wave experience. And so this was 2000. Jump forward a little bit. We get to 2009, a decade later or so. It's still fairly small, not too much. Well, March 2016, there was a particularly intense blob off the west coast for us and throughout the Pacific Ocean. You can see it in other places. They just emphasize this color here for that blob. Almost 30% of the ocean surface was experiencing a localized heat wave. Jump to June 2022, it's down to about 20%, but you can see it's spread out in many different places. Jump to February 2024, a year and a half ago, almost 40% of the surface area of the ocean was experienced a heat wave. And so it's going in the wrong direction. In addition to the physical changes, there are some chemical changes. We'll talk a little bit about that. In that a warmer ocean, the water holds less oxygen. Now, if we go back to what we were talking about, hypoxic and anoxic zones, that's just another factor on the warmer water. If you're already being in low oxygen zones, it's going to be able to hold even less oxygen. Now, the other chemical change is acidification, but I'm going to hold that till later. And instead, because we're talking about the extra heat, biological changes, marine heat waves, kind of what I showed in the diagrams. Now, mobile animals will move to colder waters if they can. And that can disrupt breeding cycles, food webs, migrations, and various other things. For example, sea turtles' sex is determined by temperature. Now, at the northern edge of the Great Barrier Reef, 99% of the young sea turtles are female. Now, hopefully, that's balanced out by the rest of the Great Barrier Reef and other places that they're being reproducing. But again, it can have some almost odd sorts of effects. Now, the mobile animals will move, and some will take advantage of the warmer water. Here's on the upper picture, Dorado or dolphin fish or mahi-mahi, depending on your name for it. That can be good if you're trying to fish for them. If they're moving out of where you're normally fishing and they're moving to warmer water, that may be a problem as a fisherman. Others will seek cooler water, or they go deeper or head towards the cooler northern or deep southern waters, except that can be an issue. The picture in the middle is snow crabs. And you may have heard that in 2023 and again in 2024, they went from having about a $300 million snow crab industry in Alaska to zero. They couldn't find them. As it turns out, apparently, the warmer waters affected the crabs and they were more active. They were used to very, very cold water. Just a little bit of more activity meant there wasn't enough food around. They starved. And the starved was for the older ones as well as the young ones. And if there are no young ones, then you have nothing to replace them when the conditions return to what they had been. So yeah, the effects are considerable, and it's something like this. They weren't expected. It's not just the prey animals, it's the predators will move too. The picture there of the diver holding that is a Humboldt squid. You can see how big that squid is, and they are voracious predators. And apparently if they move into an area, many, many fish will end up dying. The other thing that's interesting is that the warmer water seems to favor gelatinous animals, things like pyrosomes, as the picture here, or sea pickle, or jellyfish. And so again, if we're counting on the oceans feeding us, this is not a change that we really want to see. Other things happen as migration changes, migration times can change. You can see the picture there, the cycle for salmon of moving up the streams, spawning, the young ones hatch and move out to the ocean. Now, if the stream temperatures are different, it'll send different signals, whether it's for the adults coming back up or for the young to moving out. Now, if the adults delay moving upstream because the water's still warm, they may get caught in the heavy storms once they starts raining upland. Now, the young ones may leave the streams early because of the change in temperatures. They may not be fully developed because they weren't there long enough. Or as they move out, they're counting on certain foods that will be there at certain times. And if they're not there, then they wouldn't survive. And we'd already talked about plants and non-mobile animals dying. And part of that can be coral bleaching, which we haven't talked about yet. You've probably heard about it, and probably especially the Great Barrier Reef. It's lost half its coral in the last 30 years and just 30% since 2016. And there are, question, Hans?
Yeah, just a quick one. Going back to the crabs.
Yeah.
Have we seen a rebound?
They apparently have opened the crab industry again, but it's at 1/10 of its original quota. So yes, there's been a rebound, but only to the extent that it could support a very, very minimal fisheries. The hope is that it's the young that would not be trapped, that will be around for next year, so they will then have an industry. But it's still up in the air. It's a good question.
Thank you.
And so the Great Barrier Reef has lost all the corals. One thing I didn't mention in my introduction is I lived in the Caribbean in St. Thomas for 5 years, and where I got to really fall in love with the coral reefs. And it's of concern because these corals are being hit with these marine heat waves on a more and more frequent basis. If they were hit with a heat wave, they bleach because they have algae that live in their tissues. They're called zooxanthellae. And it's a really good symbiotic relationship because the zooxanthellae get access to the waste products, the nutrients that the corals will give off, and the corals get the sugars that the zooxanthellae produce. But if it gets too hot, then the corals will expel the zooxanthellae, the algae, and that's why they turn white. If they are still alive, they can get the zooxanthellae back. If they then die, then that's it. That's all they can do. Now, here's a picture that shows, this is again from NOAA, but the period between January 1st, 2023 and this last September. And if you look at the bottom, the colors, it's pretty much all in the brown, purple. My colors are poor, but you can see that so much of this area has been experiencing coral bleaching over the last 2 years. And if we go to the Caribbean, and Jamaica was in the news very recently. Here's Cuba, here's Jamaica, Grand Cayman, Little Cayman. I'm going to be diving for a birthday dive trip here, and yet it's been in a very, very high coral bleaching status. This was just a couple of weeks ago. So it's still continuing on. We'll see what happens. Now, there's a recent report, Global Tipping Points report, and it has, you probably have heard about tipping points. I'm not going to go into that other than to point out that their tipping points, which is consistent with what's in the Intergovernmental Panel for Climate Change, the IPCC reports. The tipping point for corals is basically it's gone past, we're above, depending on where we are, above 1.5 degrees. And so effectively what they're saying, I will never be able to show my grandkids the beauty of the coral reefs because for the most parts, they will be gone. Hans.
Yeah, I've heard that there's deeper coral reefs that perhaps are more protected. Let's put it that way.
And that's what we're hoping for. And but they need to they tolerate the deeper water because they have the zooxanthellae are adapted to limited light. If they were to move into shallower water, they may be overwhelmed by the light. And so that's why you have, like, some plants are bright sun, others are in shade. So it's that adaptation. The challenge is, will they evolve fast enough to be able to accommodate the changes? We'll put it this way: will they evolve fast enough for us?
Yeah.
And that's where it's I guarantee they will evolve. There will be these coral reefs again. Probably not I guarantee not in our lifetime. But, the ocean is amazing. The world is amazingly resourceful. But it's very good questions. In addition to the marine heat waves, you get increased algal blooms and red tides and domoic acid. You're probably seen this if you've gone to the beaches where the razor clams and mussels are toxic. Domoic acid is a neurotoxin. Its symptoms are gastrointestinal disturbances, seizures, memory loss, rarely death, but it is more common and more toxic in warmer water and more acidic water. And that has an impact on both recreational and commercial harvests. In fact, in 2023, the Oregon crabbers were not able to fish until the beginning of February because the domoic acid levels were too high. It's interesting. The interesting thing about that is one of the major sources of export, one of the major the groups that they are exporting to are the Chinese and the Asians. Now, when the domoic acid goes into the crabs, it mainly sits in their gut. When you cook the crabs, you'll take the gut, throw that away, and eat the meat. And it might be at a elevated level if you were to use the broth that you cook the crabs in to make sauces, which is the case in Asian countries. So for ODFW, they will show what the tissues are in the gut and in the muscles. So even if the even if the domoic acid's a level at too high to export them, it's still fine for us to eat here. But we are not be paying nearly as much as the price over in China. So it can affect things in many different ways. So let's see. Go. So domoic acid is produced by little diatoms, Pseudonychia. They're small little diatoms, and the clams filter the diatoms and they concentrate the toxin. The crabs eat the clams and they concentrate the toxin. Or we have the zooplankton that are filtering the diatoms. They concentrate the toxin. Smaller fish eat the zooplankton, concentrate, and on up to bigger fish and all. And that's where you can have, by concentrating it, that's why the higher trophic levels can become poisonous. Now, that happened just this last winter, where there are some of the sea lions were chasing surfers off the LA beaches. It sounded sort of funny. You can see these guys out there, except remember I was talking about the symptoms? It ends up making them crazy. And so it's an odd thing. It also has led to whales and dolphins washing up sick or dead. And it goes across the different trophic levels. The other things from heat waves, it can reduce algal productivity. Now, here's a little critter that's tiny. To give you a sense of how small this is, you can see it's 0.07 micrometers. Well, your hair is about 70 microns or micrometers. So these are 1/100th the size of a human hair. On the other hand, they are the most common photosynthetic thing in the ocean. It is a blue-green alga. And that's important because it's something like 30 to 40% of the photosynthetic organism in the tropical oceans. Now, what I'm showing here is the effect of how they change over time, over temperature. So as the temperatures get hotter, up to a good point, they're doing great. They're producing a lot more. Yet at about 30 degrees centigrade, which is 86 degrees Fahrenheit, they're starting to go over the edge. If you get up to 90, it's basically stopped working. And so that's not a big temperature difference. Those, the virtually ubiquitous marine heat waves is kind of scary if that's happening in the tropics all over the world. So that one's worth watching for. And the forgotten
Bill,
cousin.
question?
Yes, sir.
Question. These algae, the positive ones, they're on the surface too, aren't they? So, I mean, they're exposed to the full temperature, huh?
Yes and no. They are at the surface, but these guys are very, very adaptable. They can actually go be found deeper in the water. They can do better in low light than you would expect. So they're very adaptable, and they can do well in ocean conditions that have very low nutrients. And so they are highly productive in very challenging waters. But you're right. They are going to be exposed to the worst of the worst.
Thank you.
So jumping on to ocean acidification, that's all due to the CO2. The oceans are now 30% more acidic than they were before the Industrial Revolution. Now, without going too deeply into the science, the chemistry, the CO2 would dissolve into the ocean. The CO2 and water would get together and produce carbonic acid. Just put them together, you get that acid. Well, this acid likes to fall apart, and part of it is a bicarbonate, so it's HCO3 plus H, hydrogen ions. The acidification is where you have a bunch more hydrogen ions. That makes things more acidic. The pH is a weird system because the lower it is, the more acidic, the more hydrogen ions there are. Well, the hydrogen ions are interesting because they really like bicarbonate to become hooked up with a bicarbonate. Well, over on this side where we have shells, coral skeletons, things like that, they produce calcium carbonate. In order to make their shells, they need to take their calcium and combine it with carbonate ions. But those are being scavenged by the hydrogen ions. So the carbonate ions get pushed over here, and they can't make the calcium carbonate. And again, it's a balance, but the more acidic it is, the more hydrogen ions, the more it's this way, the less it's available for that. Now, that's a problem because as we continue to burn fossil fuels, put carbon dioxide in the air, that's going to continue to rise. Here's a fairly famous curve you may have heard about. It's the Keeling curve. And there was a fellow who was a very good chemist, and it started in 1958. He was measuring the amount of carbon dioxide in the atmosphere in order to get a long ways away from industrial situations. He started at Mauna Loa in Hawaii, continued that on, and long about 1988, some folks said, well, let's see what it's like in the ocean. So they did at this area in Hawaii. They started measuring the amount of CO2 in the oceans and corresponding what was the pH in the ocean. And you can see CO2 kept going up in the air. CO2 kept going up in the ocean. Acidity kept going down, which again, because the pH is negative, that means that it's more and more acidic. Typical pH is 8.1. So that's what it was. If we look on our side here, as we're getting into the yellows and such, off the Columbia River, you can see there's a big change there. Newport, you're seeing again, there are a lot of oyster hatcheries up here. That is a problem for the oyster hatcheries. In fact, here's a picture of some oysters when they're 1 day old, 2 days old, 4 days old. They have nice regular shells. In lower pH waters, more acidic waters, they can't form that. If the little ones can't form, they can't grow up to be bigger ones. Same thing goes with the crab larvae. Crabs have calcium carbonate to make their shells. In addition, they have little receptors down here that tell them a lot about what's going on around them. And those are made out of calcium carbonate. And so if these guys can't survive because they can't tell what's around them or what to make their shells, then there are no crabs. Here's a thing called a sea butterfly or a pteropod. It's actually a snail that uses its big foot to swim around in the water. It's got a shell like regular snails, but they're showing now that these guys live out in the middle of the ocean and they have to make their shell the same way. They're finding that many of these are not having their shells being made. That's important because this is one of the favorite foods for salmon. They go out and spend years out there largely eating pteropods. And so that's a big deal, not only for the young ones, the adult shellfish spend more money more energy making their shells, so they're not going to be plumping up. The oysters are not going to be as fat, so they're not going to be as good. Salmon in particular, we said they're going to lose their food with the pteropods. They also, in more acidic waters, they lose their sense of smell, which means they can't avoid predators because they use smell to find where the predators are, and they can't find their way home. And don't get me started about plastics. Anyway, with that, I want to say we know what the cause of this is. It's CO2 and other GHG emissions. We know the result: hotter air and oceans, more intense, persistent, and deadlier storms, more local heat waves, changing ocean currents, ocean acidification. And the solution? Any suggestions? What should we stop doing?
Stop polluting.
Burning fossil fuels.
Right.
All right. Now I've run out of my throat. So any questions? And I do appreciate the questions that you posed. I appreciate the back and forth. So thank you. Hans.
Yeah, I've heard that there are people studying, and actually a nephew of my wife, he's at Woods Hole, and they're working on trying to study the chemical actions in the ocean and seeing ways they can speed them up, especially speeding it up insofar as leading to keeping the calcium in such that the animals can actually access it.
Right.
And I assume you've heard about ideas like that.
Yeah, there's a lot of study and trying to find options how to do carbon dioxide removal, which is okay, except that if you remove it by putting it in the ocean, then you have to deal with the acidification. If you were to then put in some base, some sort of buffer to that, then you're playing with a really complex system. And that complex system is complex. That sounds sort of obviously redundant, but understanding how it all fits together is a real challenge. I mean, I'm a skeptic about the geoengineering, which that kind of goes in toward. I think we do need to understand what we can do with that. I'll stop sharing here. And we need to figure out, let's stop the problem, which is the burning fossil fuels, as well as looking for alternative ways of doing things. Any other questions? Jim?
On the map of Oregon, it showed that the ocean was more acidic at the Columbia and at Newport. Have any idea exactly why that would be, just in those areas, or? I
hesitate because I'm not a marine chemist. I hesitate to say anything too definitive, but I have a feeling that as the water is coming out of the Columbia, it's going to have a variety of its chemistry is going to be different from the full seawater. Admittedly, it's tidal, but my guess is that there is something going on there that is going to be influencing the amount of acidity, the amount of sort of the pH of the water anyway. It is interesting to notice that it comes down the coast, which is a real big impact to the oyster hatcheries. So, and they were the ones that really raised the red flags, going, they suddenly had no of their baby oysters, their spat, that they were able to then sell or to grow out. So,
but haven't they found a way to improve that situation?
Yeah, it's a matter of having to make sure that you buffer the water that's coming in, and by knowing there's a problem that varies different times, you monitor that, and most of the time everything's fine. If you're monitoring it and things start going south, then you can then do the buffering and things like that. So yeah, they've managed it, but it would be nice if it was a matter of solving the problem from the beginning. Karen?
Have you read any studies about razor clams? Because I don't know, that hits really close to home for one of our favorite foods. And it just seems like the seasons are closed a lot more often these days because of the toxins and things. But it's just this informal thing that I've noticed, but I don't know any data.
You're right. And it's actually the Oregon Department of Agriculture does the domoic acid sampling, and they can't open up I think it's the clam season, razor clams or mussels, or the crab season until they have 2 successive weeks that it's the concentrations are below area levels of concern. But if you have any questions, it's easy enough to just Google or go to the Oregon Department of Agriculture and see what the domoic acid levels are. I haven't done it, but my guess is that they would have graphs or data sets that would show how often it's exceeded the levels. I will say that they are more common. The algae is more common when the water is warmer.
Yeah, that's what. Thanks.
Yeah.